So, welcome back students. As discussed in this earlier lecture, today basically will be the final lecture of this entire coursework, and today what we are trying to do, I have picked up a molecule medium sized natural product as a target molecule, and we will try to explore all our acquired knowledge. So, that your main idea or take home message should be, if you are given a target, how you should approach the molecule from its initial perspective, means first start with a visual dialogue, then do the psychobiology of the synthesis or psychoanalysis of the synthesis, means your visual thing will start at the beginning, want to see the molecule, then try to apply all the tools which you have already acquired. Tools means you apply transformation based strategies, functional group based strategies, starting material based strategies, try to analyze the key structural features in the given molecule. If there are some stereochemistries involved, that is very important. Then if the molecule is topologically unique, try to analyze its topology and then try to figure it out whether topological based strategies will be of any help, and then finally do the forward synthesis and try to complete the story. So, the molecule which I am now going to discuss, the molecule structure first I am going to write it down. The structure of the molecule, basically we have already discussed similar kind of structure, is angular triquinone. Triquinone, we says triquinone is a very interesting framework or a topology based framework, which is very much abundant in the nature, and this particular angular triquinone is a unique class of natural product. And I have seen structural features. The molecule is named as isocommine. It is a angular triquinone, it falls in the class of angular triquinone. The molecule does not have any active functionality except a olefinic unsaturation. The synthesis which I am going to discuss is first reported by Professor Michael Pirong in a JACS paper. If you want the paper, I can send it to you. This was done in 1979, quite long ago. Now, this particular molecule, as I said, if you count the number of carbon, it is a tricyclic sesquiterpene. Sesquiterpene, we often says they contain say 15 carbon in its framework. Now, start counting it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then you have this 4 methyl which counts for C15. Now, as I said, initially start the visual communication with your molecule. Visual communication means your visual dialogue. Now, initially I said you need to find it out what are the key structural element in this given molecule or key structural features. Now, if you see its structural features, I will try to write it out. This molecule has a compact tricyclic, I will write it down, compact tricyclic skeleton. But the tricyclic skeleton has a unique topology. Having a unique topology means is angularly fused. Now, which is the topology? Is angularly fused. Angularly fused. The AB two ring is linearly fused with this series angularly fused with the AB ring. It is angularly fused. That topology is pretty important. Now, the next part I am saying 4 contiguous carbon which basically is stereogenic. Stereogenic basically we are not going to discuss about the stereochemical strategies, but if you see what are those is the 1, 2, 3, 4. Now, contiguous means they are basically kind of continuous, they are continuous array, there is a continuous 4 contiguous, you can just say stereogenic center. Okay. Then you are having 3 quaternary, 3 all carbon quaternary center. You see this 1, this 2, this 3, this is also contiguous, 3 all carbon quaternary centers. So, these are the main structural features which will be seeing in this molecule, and from the very beginning you can say that as there is no active functionality, probably some type of redundant functionality you have to think about. Anyway, we will try to analyze how these things can be done. So, now coming to the retro, coming to the initial retro, we first start doing a mental analysis by the information which was given to us at this moment. So, the starting material the target we will first write it again. The target is basically complex, it is not that easy target, it is not that easy target, because there is absolutely no functional group. So, initially I am saying that as this target, it is the only active functional group is a methyl functionality, probably this olefinic unsaturation can be created by a simple elimination reaction which all of us quite familiar. The stereochemistry part is basically we will keep it as it is. I am saying that if you are having this 3-degree carbonium ion which can eliminate this hydrogen. So, this is basically a FGI, simple FGI, it is a normal elimination. Okay. Now, fine, now this carbonium ion how you can generate? The 3-degree carbonium ion absolutely stable, there is no issue. So, if you can put some OH or something here, it is possible, it is definitely possible, but what you say this 5 member this particular array probably seems to be little bit complicated structure. Normally 5 member ring containing starting materials are easily available, but as we have generated a 3-degree carbonium ion, we are just wondering if this kind of carbonium ion can also be generated by some rearrangement or some migration. So, now we are trying to guide you through another reaction which I am now basically focusing. I am just proposing the retro as the synthesis was reported by Professor Pirung, we are trying to exactly follow the retro which he has devised. The Professor Pirung says that if you have this kind of carbonium ion, this is also 3-degree. Now, this is a 6-member ring fused with a 4-member ring, angularly fused with a 5-member ring. Now, what was proposed if this carbonium ion is generated in the reaction mixture is a 4-member ring. So, a cyclobutane overbed. So, now you try to apply your topology based strategies, the cyclobutane overbread. So, your topology is coming into picture. We said that in the overbread intermediate you create some intermediate which will be definitely strained. Now, if it undergoes a 1-2 migration here, you will get the another 3 degree carbonium ion, but the strain of 4 member ring has been released, fine. So, you get this 5-5-5 system. Now, obviously, what will give you this 4 member ring axis? Now, 4 member ring, as we said, we already discussed that the most elegant way to access 4 member rings is 2+2 cycloaddition reaction, fine. We will now try to analyze how it can be done. Now, I was saying that if you having this particular compound in the beginning, you just do a FGI through a methyl lithium addition. So, take this ketone, do a methyl lithium addition, then do the water elimination. So, this is the FGI functional group interconversion. So, your functional group based strategies is applicable. Okay. Now, we are trying to analyze the, we are saying that a retro 2+2 would be probably feasible. Now, what I am saying? I am saying that okay, if you have compound like this olefin and then I am draw it in this way, that if you have this compound, a substituted cyclohexenone system, you can easily do a 2+2 reaction. Now, what is this? This is your key transformation. So, your transformation based strategies is coming into picture, fine. Now, I am saying that okay, so you are almost close or something like that. So, next I am saying that this particular appendage you can easily construct it if you have a compound like this particular compound, if you have a just putting a appendage with this. Now, this is basically a appendage based disconnection, which is also we covered in the functional group based strategies, FG based strategies. Appendage, how to disconnect by simple FG based strategies. Now, we are saying that okay, this particular compound you can easily I mean you can basically do this entire transformation by if you are having a this particular 1,3 diketone derivative and you do a Grignard reaction. Now, this kind of allylic transposition we have already talked about. This is a very unique transformation. If you remember earlier we talked about this allylic transposition. Means the allylic double bond has been kind of rearranged, this from this here it basically rearranged to here with this incoming nucleophile, and then simplifying the starting material you can then try to figure it out that this could be easily start from this 1,3 cyclohexadione. So, this is basically a starting material based strategy. So, now we will try to analyze how this starting material can be related to the intermediate. Initially, if you see a methyl group has to basically introduced here. So, what we try to do, we will just use a LDA methyl iodide, because most acidic hydrogens are here. So, the first methyl which is introduced in this way. Now, this compound is 1,3-diketone. So, it will be seems to be tautomerized and will exist in particularly this kind of enol ether. This is known. Okay, now, this enol ether, now we see the structure, this there should be another methyl which needs to be introduced at this carbonyl. So, again we will be doing another round of LDA, THF and methyl iodide. Now, you will be getting this compound. So, 2 methyl group has been introduced. Now, your allylic transposition has to taken place. Now, the particular appendage which you need to introduce will be having, just go back to the earlier page, you will find that you basically need these appendages. So, what we try, we will take a Grignard something like this and we add to particularly these things. Now, we will say that this Grignard we write it as a RMGBr to explain the mechanism to you. So, here is the OET, here is the methyl, here is the methyl, the Grignard is now OH R, R is the entire group. Now, I am saying this allylic transposition, you just react with a aqueous acidic workup. The vinylic ether will be first hydrolyzed to give you OH. You have a methyl here, you have a methyl here, you have a OH and R. Now, this vinyl ether will now tend to rearrange its double bond to give you a ketone whose structure is this methyl is there, this double bond is there, this R. So, now this is your allylic transposition. So, now we will be again writing the particular intermediate which we got. Now, this intermediate, if you now draw this structure, let us draw it in this way. There are 3 methyl double bond, these things. Okay. So, things are now ready for this cycloaddition reaction. Now, this cycloaddition reaction, it was done in a HNU, a 350 nanometer light source was used. It is found that the cyclohexanone, the relative stereochemistry of this particular product which you obtained after the cycloaddition is basically this one. Now, we are just trying to analyze how this stereochemistry you might get. I am saying that the parent cyclohexane might exhibit in this conformational behavior, because this is a half chair kind of thing, and then you are having this, and then this double bond. Okay. And then your the methyl, this methyl and this methyl is a pseudo equatorial, pseudo axial. So, this methyl is seems to be the below and this methyl seems to be this way. Then this is 2 plus 2 takes place, and finally the stereochemistry of this cyclic product which you will get, the methyl is below the plane, hydrogen is here. Now close this ring in this way and then try to figure it out the cyclopentane ring. Now here you say that the transition state will be trying to have this methyl below and this methyl will be above in this cyclobutane ring to avoid the steric interaction in the TS. So, this relative stereochemistry also you can explain in terms of ground state conformational energy, and then so you have this overbread, it is kind of overbread. You are basically, so this topology linear 6 4, so 6 4 and 5, this topology you have been basically created. Fine. Your next part will be quite easy. So, next what we do? You do a simple Wittig reaction. So, Wittig reaction will basically giving you everything remains same. This is your methyl, exocyclic double bond will be just created, right. Now, before this final step of this reaction, I will try to give you another thing. If you see the target molecule, we are basically having a 5 member in the linear fashion. So, this structure is having a topology bicyclo 3 3 0 3 3 0. Now, what you are saying that this particular topology can be constructed if you having this carbonium ion which is now bicyclo 4 2 0 4 2 0. We are saying that this is overbread. So, this is overbread and this is having a strained 4 member ring, it will basically undergo 1-2 rearrangement. Now, this particular rearrangement sometimes referred as cyclobutyl carbonyl cation rearrangement, carbonyl cation rearrangement. So, this particular cyclobutyl carbonyl rearrangement. So, it basically says that if you having a system like this, it will tend to rearrange to give you a more stable cyclopentyl cation. So, okay, we are almost finishing stage of the synthesis. So, now we will again draw the structure of the Wittig intermediate which we obtained. Now, this exocyclic double bond is here and your overbread is basically here. Now, we will be doing the standard cyclobutyl carbonyl cation rearrangement. So, this compound was just subjected to a little bit acid, simple acid, probably not too strong acid, paraffin sulfonic acid. It is found that initially you get this methyl remains same, all the relative stereochemistry remains similar. Now, this is what this we just now explained is a cyclobutyl carbonyl cation. Now, this cation is a overbread, it is basically overbread is overbred, and this will basically migrate to here, and if it migrates you will basically get the cyclopentane system. So, now you try to figure it out, you will get the cyclopentane system, and this cyclopentane system will now having this one is the ring fused here, no sorry, this methyl is not here, this is basically here. Okay. This structure is, I did not write it, okay. It is just small mistakes. So, then you will get this angular methyl here, and this methyl you get these things, and you get a this methyl, fine. So, a cyclobutyl system is undergoing rearrangement to a cyclopentane based system. The strain has been released, the only thing is now your elimination. So, this elimination now takes place, and then you basically get the final product, your methyl is there, your double bond and this methyl. So, target molecule now has been achieved. Now, if you try to do the summary of the whole synthesis, write transformation, functional, starting material, we say these things we always combine. So, transformation what you used, the key transformation, a 2+2 photocycloaddition, it was absolutely useful. Before that we basically use this allylic transposition system, allylic transposition of this kind of vinylic ether to give you a target molecule something like this. This is a transposition we used, and we also used this overbed based intermediate, which will falls into the class of topology. And in addition we have also explained the stereochemistry, which gives you final access of this target molecule. So, now as we are having relatively few minutes left, so this particular retrosynthesis, if you can now try to formulate, there are 6 guidelines as you say. Starting transformation, starting material, functional group, you should always combined in 3 aspects. The symmetry will be coming into picture when you are dealing with the symmetrical molecule, and we said mainly sigma V or C2 is very important. Now, C2 is also very important when you are talking about a C2 symmetric molecule. We explained today core expansion and dimerization strategy. Topology is absolutely important for cyclic molecule, and the molecule which we have just now discussed, isocommine, has a unique topology. And finally, stereochemical strategies is very important when you are trying to make the molecules in enantioselective selective or enantio pure fashion. So, we basically need to be master on all these 6 different aspects. Now, to gain enough control of your entire design or entire pathway, you basically need to know what are the transformations or unique transformation. standard transformation are known in the literature or textbooks, but sometimes very unknown transformation. For in this lecture we talked about some reaction like Demeo reaction, Barton nitrile ester photolysis, Akma-Twitch reaction. Those reactions probably are not explained in detail in many textbooks, but those are very important transformation. Now, starting material and functional group, you basically have a close analysis of the functional group in a given molecule, then try to correlate the starting material, and then basically transformation is your linking point between starting material and functional group. That is what we said. SM, TF and FG should be in a combinative fashion. Symmetry will always come into picture. Symmetry has a nice aspects, and as we discussed, symmetry controlled reaction we haven't discussed. Topology is a very unique feature. Stereochemistry definitely the core features, but you need to be master on that topic, because stereochemical phenomena to have a deep understanding, you need to visualize the molecule in a 3-dimensional way, and what are the governing factors to dictate that whether you are creating a when you are creating a new stereocenters, what will be the absolute configuration of the newly generated stereocenters. So, try to follow the entire lectures. As entire lecture I have gone through a standard writing methods. There might be some minor mistakes which I may have overlooked. So, if you find some mistakes, you just try to point it out that sir you did some mistake. I will be happy to rectify those things, because it happens sometimes human error comes and we do some mistake, because entire part I am just drawing it. So, in the drawing process maybe I do some mistakes. Try to solve the assignments. The assignment solving will basically help you to boost your confidence. Even if you see that entire coursework, we just followed the tradition of a assignment solving approaches. We give you couple of assignments or problems, then to solve those problems what are the essential knowledge you require. Sometimes some of the reactions I may not discuss in detail about their mechanism, because time is not there, but I have given you enough hint. When sometimes I may not write something, but I talk little bit more words. So, try to listen what I said, and then the keywords, based on the keywords or key transformation which you have written, maybe the stator reaction, the mechanism was not explained in detail, but stator reaction if you can give a search in the standard search engine Google or Wikipedia, you will get the information. So, those information will basically help you, and as it is a 30 hours course, definitely it is a kind of condensed course. So, you have absolutely no control of the time. Sometimes many important reactions we have to overlook due to time constraint. So, that is why assignment solving will help you to give you a very assignments which will be provided to you, and try to solve those assignments. And if you have doubt, we can clear the doubts. Doubt clearing is a very important session. So, any doubts you can always get it clarified by me, or you can consult your respective teachers who will be helping you to clarify the doubts. But as I am saying, the organic synthesis chemistry, organic synthetic chemistry, or particularly principles of organic synthesis, retrosynthesis is absolutely or immensely important subject. If you want to excel, want to explore further dimensions, further horizons in this particular field, go through the lecture notes, go through the assignments, and try to get more information from outside sources. There are plenty of sources, as I said. Scene Archive is a very good source to give you a first hand information, and if you start liking this particular subject, I will be very happy, because and then coming for the exam purpose, these exams like all India based competitive exams, NET, GATE, JAM, all those exams, probably if you start solving their question papers, you download their question papers for last 10 years, try to solve it, particularly this organic synthesis based problems. If you have doubts, you can just go through the lecture notes. If the question answer was given is fine, otherwise try to solve it based on your knowledge which you gained through this coursework. Now, again I will stop it with this particular word. Organic synthesis is such a discipline, you can basically love it or hate it, but you cannot ignore it. Okay. So, have a good time, have a safe time, till then goodbye, thank you.